Okay, we have a 150 Newton force applied to a wooden crate. We'll pay attention to that at an angle of 30 degrees above the horizontal. It's at a constant velocity and it's on a horizontal wooden floor. So wooden crate, wooden floor, dragged at a constant velocity. And the first question is calculate the magnitude of the horizontal component. So what are we looking for here? We're looking for this horizontal component, and we have a right triangle here. So we're looking for F. I'm going to call that Px for force of pull, and we'll call that Fp. So we have adjacent, and we have the hypotenuse. So that's going to be cos theta is equal to the adjacent over the hypotenuse, and that's going to be cos 30 is equal to Fpx over 150 newtons. And if you do the math, you cross multiply on that, that comes out to 130 newtons. Question 2 says determine the magnitude of the frictional force acting on the crate. Well, if the crate has a force of 130 newtons acting to the right, and it's at a constant velocity, that means the acceleration is 0, so the net force has to be 0. So the frictional force has to be 130 newtons, the same as Fpx. And lastly, it says calculate the magnitude of the normal force. So we know that with kinetic friction, that Ff is equal to mu Fn, and because it's sliding, the surfaces are sliding, it's kinetic. So we can look up on our chart here, wood on wood kinetic, that's 0.3. So we know that the friction's 130, and we can say 0.3 times the force normal, and when we do the math on that, the force normal comes out to 433.3 newtons. The diagram below represents a box sliding down an incline at a constant velocity. Which arrow represents the direction of the frictional force? Well, the box is sliding down the incline, and we know that kinetic friction acts opposite to the direction of motion. So if it's moving down the plane, then friction is acting up the plane. Okay, we've got a 4 Newton force applied to a 0.2 kilogram block of copper. Copper and steel, so these surfaces are probably going to get used with the coefficient of friction. And the first question says determine the weight of the block. So that's an easy one. That's just fuga muga. So that is going to be 0.2 kilograms times 9.8. And when you do the math on that, that gives you 1.96 newtons. Or we could probably write 2 newtons. Okay, number 6, calculate the magnitude of the force of friction acting on the moving block. Well, it's moving, so that tells us it's kinetic friction. So we use mu Fn, and that's going to be K. And there are a couple of little tricks here we have to look out for. So the first thing is that it's copper and steel. So we've got copper and steel, and it's kinetic. So that's 0.36. Now, here's the tricky bit. The box weighs 0.2 kilograms. So that's its weight down. But there's no other forces besides the floor pushing up. So Fg is equal to the force normal. So our force normal here is the 1.96 newtons. So do the math, and that gives you 0.7 newtons. Determine the magnitude of the net force acting on the moving block. So to do this, we're going to write a net force equation. F net equals ma equals, and what forces are acting on the block? Well, if we call to the right positive, then we have a force of pull to the right of 4 newtons and a 0.7 Newton force of friction. So that would be the force of the pull or the push minus the force of friction. So F net equals ma is equal to 4 newtons minus 0.7 newtons. And subtract those two, and that's 3.3 newtons. So that is your net force. Now, I'm kind of surprised they didn't ask this, because the next obvious question would be, what's the acceleration? And if we put the mass in, 0.2, we could divide by 3.3 and get the acceleration. But the question actually asks, what happens to the magnitude of the velocity? Well, we know that there's a net force, so we know it's going to accelerate. So what's the velocity going to do? The velocity has to increase. Okay, we have an 8 Newton block accelerating down a frictionless ramp at 15 degrees. And it says, what's the magnitude of the net force causing the block's acceleration? So I'm just going to redraw this because I like doing these with the ramp this way. And it's the same answer, you just flip it. So we have our 8 Newton block. So there's our force of gravity. And we have our axes. We're going to break this up into x and y components, like that. So this right here is our FGX, this is our FGY, and this is our weight, FG. So what are we looking for? It says, what is the magnitude of the net force causing the block's acceleration? Well, we have a force normal here. These two forces cancel each other out. This is the only force that's in the plane of acceleration. So FGX is the net force. So we're looking for this side of the triangle. Remember, this is a rectangle, so FGX here has to be equal to FGX down here. This angle theta here is equal to this angle theta in here. So we have the opposite and we have the hypotenuse. So that's going to be sine theta equals opposite. That's our FGX over the hypotenuse. That's our weight, FG. And we have 15 degrees is equal to FGX over FG. Now, that's not the mass, newtons, that's the weight. So we don't have to multiply that by 9.8. And then we just do the math on that, and that comes out to 2.1 newtons. What is FGX in this case? FGX is F net, because there are no other forces acting in that plane. A child pulls a wagon at a constant velocity. Okay, that's important there. Along a sidewalk. A child does this by applying a 20 Newton force on the handle, and it's at 35 degrees. What's the magnitude of the force of friction of the wagon? So we did this before. I have to just be a little bit careful here. We're going to break this force up, and we know that we've got a vertical component and a horizontal component. If it's moving at a constant velocity, then this force right here has to be equal to that force, so they cancel out. Net force is 0, acceleration is 0, and it's moving at a constant velocity. So our FF is going to be equal to F pull X. So all we have to do on this one is find that horizontal component. So we have FP is 22 newtons, and there is our FPX, what we're looking for. This is 35 degrees, and we have our right triangle. So we have adjacent, we have a hypotenuse, so that's going to be cos theta is equal to adjacent over hypotenuse, and that's going to be cos 35 is equal to FPX over 22 newtons. Cross multiply, FPX comes out to 18 newtons. And that force right there is the FPX, which is equal to the frictional force. So that's our answer, FF.